it's very exciting for me to welcome Ming and Eric here on stage for welcome then represented the whole JupyterHub team for the presentation on what's new and exciting. And I'm very excited to hear this presentation.
Yeah, that's actually exciting.
So a few people are joining us in the last minute. So welcome. This will be a presentation from Ming already here on the stage about new exciting news from JupyterHub. So without any further ado, Ming, the stage is yours. Thank you.
Thanks. Yeah. So I'm here representing the JupyterHub team, lots of folks, and especially Eric, who was working together with me on this presentation. I'm going to talk about what's going on in JupyterHub, what's new, exciting that you might want to check out, so you can stay up to date with the project. And to talk about JupyterHub, we always have to establish a little bit of context about what all these things are, so that we know what we're talking about for folks who might not be as familiar with what we do. So the JupyterHub subproject, we tend to focus on solving problems of deploying Jupyter, things like interactive publishing, like, in Jupyter we have this concept of a notebook. You can run it. In JupyterHub, we try to solve the problems of, okay, so where do you run it? How do you run it? And related to all that work, we have some projects involving the challenges of reproducible environments and the actual practicalities of reproducible and open science, and generally across the board, lowering the barriers to access of all the wonderful things that people are doing with Jupyter, making it so that people can see them, run them, and all these things. And so who do we solve these problems for? Lots of different kinds of things. We work with folks running little one-off workshops, large research institutions, small research institutions, people in education from primary and secondary schools all the way up to universities and graduate centers. Also collaborating with supercomputing centers, and then businesses running internal analytics and things. So frankly, it's just everyone. If you want to deploy stuff with Jupyter, then there's a good chance that JupyterHub, people around JupyterHub are the people you want to talk to figure that out. So taking a little bit of a step back that for this community might seem a little silly to start out, but I'm going to start out with, so what is Jupyter? So a lot of us think of Jupyter as, we have our document with code and text and as output, and it's this interactive environment. But from the perspective of JupyterHub, what Jupyter really is a web application. It's this collection of processes that are accessible over the network. And that's kind of what's relevant to us as JupyterHub, is that that's a thing that we want to put somewhere. And so why did we, as a Jupyter project, decide to write it as a web application? One is it was the cross-platform development toolkit we knew how to use. So it was the way that we could get it on Windows. But more than that, you can run, as soon as you're talking over the network, that network doesn't have to be localhost. We may have chosen it for one reason, that the localhost network connection running a server on your laptop is kind of an implementation detail of a regular desktop application. That's how a lot of people really interact with Jupyter, as a desktop application that happens to put the UI in your browser. But because it runs over the network, the server and the UI can be in different places, and that can mean everything from running on the cloud, on a research institution, on a supercomputing cluster, anywhere. And in JupyterHub, we have this view of, so you as a person deploying JupyterHub, you have some computers, or considering deploying JupyterHub, you have some computers. You have some humans who want to use those computers, or maybe you have some humans you'd like to use those computers. And JupyterHub is the tool set to help you connect those humans to those computers. And so it is an application for deploying Jupyter servers on behalf of users, and it's arranged in this collection of pieces to solve the different parts of, so you have some humans what does it mean to identify who those humans are? And so you have computers. How do you ask for those computers? So the key pieces of JupyterHub are there's a proxy that sits in front that handles all the routing so that the user, each user is talking to their own server. And it's the regular Jupyter server that once you're running, there's really nothing special about running in JupyterHub versus running a regular notebook server. And then there's the authenticator that is an interface for how do I identify who these users are. So maybe you log in with your institutional material or your institutional credential system or GitHub OAuth or whatever, or one-off passwords for anonymous passwords for a simple workshop where you don't actually want any real accounts, but you need something. And then the spawner is the abstraction that gives us, so you want to ask for a computer to run a notebook server somewhere. That could be, the simple version of that is just spawning a subprocess. Just launch notebook servers on the computer that you're running on. Or maybe they're spinning up whole VMs. Maybe they're running in Kubernetes. JupyterHub doesn't care. JupyterHub says, please start a notebook server for me and just tell me the URL for where it is. And then finally, the server is what you actually run. Right? This is the part where JupyterHub gets out of the way. It's time for the user. This is the point of this whole thing, is getting users to talk to Jupyter servers. And then the hub is just what we call the thing that connects it all together. So these three pieces, the proxy, the authenticator, and the spawner, these are all interfaces that JupyterHub defines that accept multiple implementations. So you can say, I would like to use GitHub OAuth and Kubernetes spawner with the traffic proxy would be one configuration that you can do. And so whatever version of these that you want to use, you can either pick an implementation that someone's written, or you can follow the documentation and write your own implementation if nobody's written the one you want yet. And they're fairly small APIs and mostly not the hardest thing in the world to write. So the first part of, now that we're kind of all on the same page, is what's new? What have we done recently that you might be interested in that we want to highlight as a project? So during the winter and spring, we had 3 outreachy interns with the project. So interns working on projects, adding things to JupyterHub and adding things in the Jupyter ecosystem in general. And the first one of these I want to highlight is improving the accessibility. So Blessing was an intern working with me who was learning accessibility auditing tools, learned a lot from the Jupyter accessibility team. And we learned a lot about how we can improve the accessibility of JupyterHub in particular. And that's gotten quite a bit better in the last few months. Another intern, Alan, who couldn't be here but had presented a recorded talk earlier today, worked with Sarah Gibson on reorganizing our documentation according to the diataxis framework, and I'll encourage you to watch the recording of his talk when that becomes available. And it really improved a lot of how our documentation is organized and navigated. And I learned a lot about how to write good documentation from this process. And I'd encourage folks to check it out. More on the technical side, there's been a lot of work, we've got a lot of folks who are involved in the day-to-day maintenance of software, and a lot of what we do is Kubernetes related, and testing things against Kubernetes can be a bit of a challenge because in your test suite you have to deploy Kubernetes, and then you're running the tests and then something goes wrong. How do you figure out what went wrong? The single most important thing in your testing tools, in your testing framework, in how you write your test is what information do you get when the tests fail. Right? It's not just did all the things work. You want, when something's wrong, you want to actually know what's wrong. And when you're running tests in Kubernetes, which has all these abstractions of, the process, there's a bunch of things running at the same time. They're running in different places. You don't want to say, oh, it didn't work, right? Unlike PyTest, you're not even going to get, you're not even going to see the code that you wrote is not running in the same place where what's captured by a CI pipeline. So one of the things that folks have put together is this the Kubernetes namespace report, which is one of my favorite things. Because what you get is, so the test failed, and now you get this really nice report of, show me what's going on. Oh, there's an error there. It found, show me, for all the pods that there's an error, show me everything about it that it can find. Show me the logs, show me its properties, and then I can see down here in all this stuff, all this information, I found, oh, I called a function that was missing a required argument, right? That's the kind of error that we make all the time, and they're easy to fix, as long as you actually see the error. And with a lot of these tools, when we're working with deployments and things, just finding the error message can be really challenging. And so some of these tools have really made our lives better in terms of maintaining these things and actually getting that feedback from continuous integration to actually be useful, actionable pieces of information. On the other side of when you're actually running JupyterHub, so a lot of folks run JupyterHub in Kubernetes using our 0 to JupyterHub Helm charts. You want to monitor what's going on in your hub. How many users are there? Who's using a bunch of memory? Why have things stopped working? How many errors am I seeing? And there are a lot of tools and instruments for monitoring this. Prometheus and Grafana are big versions of those. But writing a bunch of your own Grafana dashboards and saying, like, what do I want to see, right? That can be fun and interesting. But there's a lot of things that are fairly consistent that are useful to most people deploying JupyterHub. And so we've been working on some of these Grafana dashboards so that you can just say, here's a default dashboard that should get you a lot of useful information. So this is a project we're working on in the JupyterHub org that gets you Grafana dashboards for without having to write them all yourself. So a big highlight on the JupyterHub front in general is we have a major release. We've in fact had 2 major releases in the last 6 months, 3 and 4. So what are the significant changes there? So these are, well, they're both major releases. I would call them small releases. So we have somewhat strict rules of what changes constitute a major revision. And so if there's any, when you upgrade JupyterHub, sometimes there's a small database migration that needs to happen. Sometimes it's a big one, sometimes it's a small one. In both 3 and 4, there were little changes, but they require running the database migration step. And so that means that these are major revisions, even though most people shouldn't really notice these changes. So even though there are 2 major releases, they shouldn't be very disruptive and should be quick and easy to upgrade. And they're little things like dropping Python 3.6 support or some changes to how we check cross-site request forgery tokens that most people shouldn't notice. But a lot of the interesting changes in JupyterHub are related to facilitating sharing and collaboration in JupyterHub. And I'm not going to go into the details of what all those changes entail. There's a lot of granular permissions and which objects have scopes assigned to them, but I'm going to talk more about what are the use cases that we're enabling with these changes. So we have some contributions, including some more in the admin UI. You can attach properties to groups to more easily manage at runtime, saying like this, when you have a lot of different groups of people who are allowed to do different kinds of things in JupyterHub. Like maybe these people are allowed to use more resources, or they're in these classes, so they should be using these images. Being able to manage that both coming from the authenticator or manually in the admin UI. There are tools for allowing different users to have different experiences in JupyterHub, and there are a number of improvements in that direction. We also have improving support for real-time collaboration. So there have been a couple presentations covering what real-time collaboration in JupyterLab is. And this is when you have 2 people talking to the same Jupyter server. It works sensibly now, which hasn't been true in the past. But when you have that, you need to have, there are these APIs in Jupyter Server now for an identity provider. So that's how do you tell who this person is, and an authorizer, which is what are they allowed to do. And so JupyterHub, whose main responsibility is implementing authorization and authentication in Jupyter Server, now implements these two APIs for an identity provider. So when you have real-time collaboration set up in a JupyterHub deployment, you can see the users with their real JupyterHub credentials, and collaboration works. In the JupyterHub context, there are a lot of considerations in terms of, do you want to allow someone to run code as you? So do you want to grant them access to your server? That may make sense in a student and instructor context. It may not make sense in some other security context that may not be appropriate. There are avenues that we've explored, and we have examples in the documentation of using concepts like collaboration accounts. So there's an account that is a user, but doesn't necessarily represent any individual human. So you have multiple people who come and they essentially act as a group. So there's no impersonation issue in that case. And because of the way JupyterHub authorization works, you can run JupyterLab as what we call a service that's not actually running as any user, but that you can specify that this group of users, TAs have access to this, and we can do things like the TAs in this class have access to student servers in that class. Also related to this Jupyter Server feature of granular permissions that now exist in Jupyter Server is you can have permissions. You can have permissions to talk to a server and do less than everything. So in this case, we're talking about, for instance, read-only access. So I can go to the server, I can look at these files, I can interact with them, I can see what's there, but I don't actually have permission to run code, and I don't have permission to save files. And the way Jupyter Server has implemented this is you can have kind of arbitrary collections of permissions. You can just, and JupyterHub is just where you store who has permission to what. So you can say, for instance, maybe you don't want to share execution, you don't want real-time collaboration, but you want TAs to be able to see, just look at what's in students, but don't actually give them permission to run anything there or edit anything there. And so all of these different models are now supported in JupyterHub. So on to a bit more of what's not done yet, but we're working on. So we're working on a 1.0 release of JupyterHub Traffic Proxy, which is the traffic implementation that now supports Traffic v2. If you don't know what that means, it's probably not relevant to you. If you do, it might be exciting. There's a significant performance improvement here where adding, when you had 500 users or so, adding one route via traffic took on the order of 10 to 15 seconds, where now it's on the order of tens or hundreds of milliseconds, which is pretty nice. We have some tools if you're maintaining a spawner or authenticator. We're working on PyTest plugins to make it easier to do the scaffolding so that we don't have a bunch of tools, a bunch of projects all implementing the same, start up a JupyterHub and then configure it so that I can test. So we're working on PyTest plugins, and Sheila is another one of another one of our outreach interns, and she's going to be talking about this tool in the next time slot downstairs. So if you're interested, I encourage you to go down and check that out. We have another major release of OAuthenticator, which has a bunch of refactors for that improve maintainability and improve the support for running authenticators with arbitrary OAuth providers. And in general, across the board, updates to lots of the things we do, mostly, especially our distributions, are being updated with the latest versions of all these packages. And in the future, we have a lot of plans for further improvements for sharing and collaboration with things like user-initiated sharing, where you actually control granting access to your own server, which isn't possible yet, and allowing your authenticator to manage some of these permissions. So on the other side of the Jupyter project, we also work on Binder, which is tools for interactive, reproducible environments. So you publish a notebook, you get a link, you click it, and then you have a running environment somewhere that has all your dependencies so that people can actually open your notebook and run it without installing anything. The components here are repo to Docker, which is say, look at a repo, give me a container image that has everything you need to run it. JupyterHub, which is saying, once I have this image, run it for somebody. And BinderHub, which stitches those two together and gives you a form to say, here, tell me your repo, and I'll build it and run it for you. And finally, we have mybinder.org, which is where we actually run an instance of this service. So some updates to repo to Docker. We've updated the default Python to 3.10. We strongly encourage everybody to specify what version of Python they're using. This is the single most common way that things break on Binder, is that you make assumptions about what version of Python you're using, but you don't specify which version. So please specify that, and I appreciate there's a reason for that, that there aren't big standards for how you specify the Python version, but if you use specifications like pip files or conda environments, then you can, there's a logical place for it. And we have runtime.txt if you want to use a simple requirements file. For old Python, which now is defined as less than 3.7, we have support for, now you can install older versions in a separate environment so that they don't interact with the JupyterLab environment. They're installed as a separate kernel. And this enables us to support versions of Python that are hard to support for the server environment, to keep them working longer, at least for the subset of cases where you mostly care about the code in the notebook as opposed to modifications of the notebook server environment itself. And we switched the default launch environment of that to Jupyter Server from the Jupyter Notebook server. Again, something that you shouldn't see, but all these transitions to Jupyter Server are hopefully making this a bit more painless. Talking about mybinder.org in particular, so this service that we operate, we've served at this point 145,000 unique repositories on mybinder.org since standing it up and collecting metrics at the last week or so of 2018. And we're in kind of a stable scenario of 8 to 10,000 unique repos launched in any given month. But we also have launched just shy of 30 million user sessions on this free public service that we operate. And mybinder.org is run on a federation of clusters, all donated compute resources that have come from a variety of institutions. So past members of the federation include a large Google and the Alan Turing Institute, and current members of the federation running now include OVH Cloud and GSIS. So looking at user sessions over time, you can see there's kind of a steep growth, and then there's a big drop-off. This is also funding related. That big drop-off happened when try.jupyter.org, which was the link that you get if you go to jupyter.org and click like, try it out. That used to be powered by Binder. That shifted to JupyterLite, which was a great deal easier and cheaper to operate. And so that caused this huge drop-off that is now kind of stabilized. And in this last week or so, we've turned off the Jupyter, so Google funding ran out, and so our largest federation member went away, and so Binder resources have significantly reduced, and now it's full during peak times. And so the future for this, so for a lot of folks, I think because in JupyterHub, our goal is serving these people who want to solve the problem of, I want to take this thing and I want to make it executable and accessible to people with minimal effort. And that doesn't have to, just because we're the JupyterHub org, that doesn't have to involve using the JupyterHub software or BinderHub software. For a lot of these folks, a lot of these use cases, the actual computational demands are pretty minimal. When we look at like the computational resources consumed on Binder, a lot of people use Binder use close to nothing. And that's part of why we've been able to afford serving so many, even though we're running a little low right now. So the kind of frontier efforts are a project called Repo to JupyterLite, which is now part of the, contributed from JupyterHub team members to the JupyterLite organization, where we're working on solving the problems of making it easier for folks to quickly and easily say, here's my repo, give me a JupyterLite environment that requires no deployment, no anything. It's just a web page. And then you're not relying on hosting other than a static file, which is much more portable, much easier, and you don't need to worry about Binder being full. So we're working on helping people in that direction. We have plans on the sustainable funding of the federation and are talking to people about adding federation members. Part of the reason we have this federation is that it means that when a big pot of funding goes away, mybinder.org doesn't go away. The capacity got reduced. It's running at reduced capacity right now, but we didn't turn it off. mybinder.org didn't go away. And an important part of that is actually donations to Binder are one of the big reasons why we didn't have to turn it off, because people said, I like Binder, I donated a few dollars here and there, and that helps us keep the lights on the core, like logging in and or not logging in, but just seeing Binder and building and whatever federation capacities we have. So now we don't pay for any actual like user sessions, but we are covering with donations and some funds from GSIS the bit of Binder that is the thing that you see when you type mybinder.org. And you can see kind of our costs, our daily costs from the past 30 days, from when we were operating the big Google member of the federation. We were in the $200 a day range, which we can't afford. But now we have done a lot of work to keep this kind of front layer something that we can manage. And now it's on the order of less than $10 a day, and that's something that we actually can sustainably cover easily enough without having to worry about. And that is largely, like, we've had these big pots of support, but they're not very flexible, and donations are a much more flexible resource that we can support just keeping the lights on. And there's a lot of things going on in Binder that mostly involve, so Binder's about tying these pieces together of building images, launching things, and the initial version of this has a bunch of assumptions of there's one version of building, there's one version of launching. Every time you build, you're necessarily launching a session, and there's a lot of work going on just kind of drawing abstractions and allowing people to make different choices and reuse different pieces of, so you're building. Now you don't have to build on Kubernetes, you can build locally with repo to Docker. You don't have to build with Docker, you can build with Podman, or when you build, you don't have to launch. You can just build and push it to a registry to be used later in a regular JupyterHub launch, for example. And finally, just highlighting the community efforts led by our community strategic lead, Sarah Gibson, with a lot of work leading a lot of the organization efforts around the outreachy internships, reorganizing our meetings into this collaboration cafe format to be more welcoming to new contributors and help us grow the community, and improving the onboarding documentation and tools and everything to help people contribute to JupyterHub. So last, what's next and what's for you? Share with everybody in the Jupyter community what you know, what you're doing. Talk about how you're using things. That a lot of people learn from each other on what they're doing. If you're a spawner, author, check out the PyTest JupyterHub talk and plugin to see if it can help you in your maintenance. Try out the new releases, the pre-releases, help things be useful for you, and then join the various community efforts and our collaboration cafe meetings, discourse, and find us on GitHub. And if you're connected to an institution or a bunch of money, you can talk to us about joining the Binder Federation. And thanks.
Thank you, Min, for the amazing work from the Jupyter team and the amazing presentation. Unfortunately, we kind of short on time, so we're going to skip the presentations. Can I have a second round of applause for me and the Jupyter team? Thank you.